In this video, we're going to start looking at authentication and authorization for the Rust plus HTMX application. And it's quite complicated. It has a lot of moving parts. So let's start with how users would be stored in the database. Let's start with an overview of what's needed. So we have the database, and it's going to have usernames / emails, almost the same. And then the simplest way you could do it is you could have the passwords in plain text in the database. So here you have test, and the password is password. Now, obviously, doing it like this is quite bad. Because if your database is leaked, someone gets access to your server, they have all the passwords and the emails and the usernames, and people typically reuse passwords for different websites and applications. So you really don't want to do that. So what's normally done is you store a hashed password. Now, if you just hash every password the same way, then now we have some kind of hash string. Let's see. So maybe here is like some kind of hash. Then if there's another user that has the exact same password, you can see that. You can see that in the database they have the same password. So that's an extra vulnerability. If you know the password for this guy, you can infer that probably this guy has the same password. You know he has the same password. Also, there is a specific type of attack that uses pre-computed tables. I don't know too much about it, but you could pre-compute a bunch of things, and then you use that to try to crack the hash. And to avoid that, what you normally do is you use salt. And a salt is basically, it's a random string, or random bytes, let's say. And you add that to the password. So the hash you get out is the salt plus the password, and let's say the final hash is hashing of this thing. Now this salt is randomly generated for each user, so that means that even though they have the same password, this string will be completely different. Like it will be, super different. No correlation at all. Okay, so this is what you normally have. And what happens when a user tries to log in? Well, they send to the server. So let's put it here. So let's say login process. The user sends the email, which is like the stand-in for the username here, and the password to the server. So then the server looks up whether it has a user with that email. And if it doesn't, it of course sends back an error, there's no such user. And if it does have that user, it finds a hashed password. So now we have a password, and we have to compare it with a hashed password. So let's say we're trying to check this. And how do you do that? Because the hashing was done with some random bytes. So we cannot regenerate the hash unless we also store the salt. So that's another thing that you store when you use this method. You also store the salt in the database. And these are like different salts, so let's different random strings. So what happens when the server gets the username and the password? You use the salt in the database, you run it through your hashing function, and then you check if that is equal to the hashed password that's stored in the database. And if it is, the user's logged in. So that's the login process. And it means that to get this to work, we need a method to do cryptographic hashing, cryptographically secure hashing, and create these salts and so on. But you know, those are just random strings. It's not so difficult. But we need a method to create these secure hashes. Okay, so that's the login process. What happens after the user's logged in? Because you don't type in your username and password all the time. When you're navigating a site, somehow the website knows that you're logged in after you log in once. So what happens is that on a successful login, the server sends some kind, the server like establishes a session, so that is how, that's how we say that when you're logged in, you now have a logged in session. And how does it do that? Well, it sends some kind of token. Usually, this is the only way I know. Maybe there's, I mean, so what happens when you navigate around a page is you don't have a continuous connection to the server. Maybe you could do something with WebSockets, but normally you don't have a continuously open connection to the server. Rather, every time you need some new content, go to a new page or download some new data or whatever, you open a new connection to the server and request that data. And that's a fully new request. The server doesn't know who you are in principle, but the way it knows who you are, so you don't have to log in every time, is that it sends you, when you log in for the first time, it sends you a token. And this token stores information about who you are, and every time you request data from the server, you send that token to the server, and the server can then use that to verify that you are a logged in user and you have access to whatever you're requesting. So it sends some kind of token that contains information about the user. And that information can be like user ID, it can also be access rights. In principle, you can put whatever you want in there. Normally a user ID is enough because you can get anything else from the database, but it might be for convenience nice to store the access rights. So you don't have to ask the database every time you want to check if the user can get some data. Now, the problem with that is that, okay, if I'm an attacker on the website, why don't I just make my own token that says I have some random user ID and my access rights are admin access rights. And the way that is handled is the token has to be encrypted. So you cannot see the content, you cannot get into the content, you cannot edit the content. And there's also an additional layer of security, something called MAC, Message Authentication Code, which is kind of inside the encrypted message that ensures that the message content has not been altered. So first of all, you cannot even see into the message, but even if you could, if you somehow had broken the encryption, there is an additional level of authentication that checks that the content is what it should be. So let me make a disclaimer that I'm not a security expert. This is just what I have been able to understand from reading up on it. So take it with a grain of salt. But the bottom line is we, in addition to doing password hashing, we need some kind of way to, we need a crate or whatever. We need a system, let's say, to handle secure tokens. And the one I found is there's a crate for Pacido tokens. Pacido stands for Platform Agnostic Secure Tokens, or token, and the crate is Pacido RS. And this is like a modern version of JSON Web Tokens, as far as I can understand, but that's not really so important. We just need a system to handle these tokens that are used for handling sessions. And in general, tokens, let's say in general, tokens tell the server that some request has been authorized by the server. Because we will also be using tokens if the user needs to reset the password, or if there is, if we also include like a verification step where the user has to click a link in their email to activate their account. That link will then include a token that needs to be secure and so on, so just not anyone can go in and activate their account, but you actually need to have access to the email you said was the email of the account. In those cases, password reset and account activation, we will also need secure tokens. And now the final thing that I already mentioned a little bit is that, okay, what do we do on password reset and also account activation? Well, we will need some tokens in the email, but we will also need to actually send emails. And what you probably want to Google if you're looking for some kind of service to do this is SMTP, Simple Mail Transfer Protocol. It's actually email, but this is the abbreviation. And as far as I know, you can use a Google account for free to send these emails. You need to go in and set it up, which we'll also look at. But we also need a crate or a system to do that. So we'll find some kind of crate. I already have one in mind, it's just not written here, that actually sends these emails. And of course, we also need a table with usernames, user emails, salt and hash passwords, and potentially also is account activated if we include an activation step. But this is a lot of stuff. There's a lot of moving parts. So in this video, we will only be looking at password hashing. The next video will probably look at secure token management. And once we have those two moving parts, we can set up some login. Then we'll set up a user table. We'll put in like a test user, and we'll try to make a login step. And then we can start with creating an account and things like that. But for now, let's look at password hashing. All right. So I also restructured things a bit. Now there's like a main lib file. There is a binary folder that keeps like small scripts. And I think this is a good place to start. So we can call this test password hash. I'm gonna write it like this. And let's have the main function. Hello password hash. All right. So to get started, we will need the crate. And that crate is called argon2, which is one I found that implements the specific argon2 password hashing function. There's also a bunch of others. Let's go here and let's make a description for this video so I don't forget. So password hashing crate. And if you want to see more generally, there's this one password this crate implements the functionality of some password hashing algorithms, and it has like a list of other derived crates with specific algorithms. So password hashing crate. Let's write that. Right, so let's go back here into this test function. And what version do we want here? So we want, let's take this version, the latest version. And let's try to run this function now. So I'm going to go over here, cargo run binary, and it's going to be test password hash. So we are compiling the new crate, and there we go. So it ran successfully. Now let's import some of the things from this crate that we need to do hashing. So let's see. Let's see some examples. Okay. I shouldn't write there. I should write over here, and let's put it over there. So we need this stuff and password hash. Let's try to start with this. Maybe we can look into what this thing is. Password hash. Okay, let's not look into it like that. So it should be a struct here, or password hash. Here it is. So password hash has an algorithm. It has a version, parameters, salt. Okay, so this is basically a hashed password. So I think we actually need this argon2 thing. So primary type of the crates API. Let's include that. And then we can default it like this, and let's try to print it. So we can have a look at it. Okay, it has a bunch of stuff. It has an algorithm, has a version. It has some parameters, which we don't really care about, and some other stuff. So Now we need some password, and I suppose it can just be a string. I don't know why it should be a byte string, but let's just have a string. And then we need to, let's just look here. Okay, apparently it has to be a byte string. Then we need the salt, as we talked about. So let's make a salt string, and we generate the salt string, and it takes some random generator. So actually we need to import these things. We need to import them. And we need to import also salt string. Let's see if we can format this. Can. So now we have the salt. Let's have a look at the salt. And we don't need to look at that anymore. Let's actually go here. Test password hash. So here we have it. So you can see the salt string is just some random probably 64 bit encoded string. So what's the next step? We have the password, we have the salt. We also made the interface type, let's say. Now we can generate a hash. So we'll take the password and a reference to the salt, and let's just unwrap it, and let's print that. And right, so we have to include a trait, it seems like. Alright, so here we have the hashed password. You can see it contains some information, like what algorithm was used, the version, the parameters of the algorithm, the salt, and the hash. So it contains everything you need to take an incoming password and check it against this hash. Right, you need the salt, which is like the random input to the algorithm, and then you need all sorts of like parameters and what algorithm was and so on, of course. So that's great. Let's try to verify it. So to do that, it seems like we need yet another trait, password verifier. So now let's say test password is the same. Maybe there's another one which only has one S. And then let's say result 1, then we actually need to create yet another version of this thing, but I think we can just reuse it. So we reuse verify password, we run it on the test password, and we run it against the password hash. So, and we can have result 2, and then we can print them. And let's get rid of that. And this stuff has to be a reference. And now let's try to run it. Takes a while, but you can see the first one was okay, the second one gave an error. So it's like a result type, which you can also see here. And let's say, just out of interest, if it's okay, we don't do anything. If it's an error, I want to see what this is. I want to see what it is. So maybe we just, let's try to print the error. Don't know if it's printable, but it seems like it is. Okay, so the error seems to, maybe it's just a string, I don't know. No, it's just some error. Okay, it just says invalid password. So that is not very helpful. Now, so this is basically the process for, first of all, generating a hash password and then checking. So let's say generate password to store in database. And then this section can be verify incoming passwords. All right, let's make it a bit bigger because we don't need that anymore. Now this guy, let's comment this stuff out and let's print this one again and let's run it. This guy, the password hash, is a very complicated structure. How do we store that in the database? Luckily, they have made an interface or a function, let's say, where you can just turn it into a string. So let's say password hash string. We can take the password hash and we can call it toString. And now it becomes just a normal string that we can store in the database. And you can see it actually encodes all this information, like it's a simple serialization of this information. It tells you the version, tells you the parameters, and we can even see the hash is here. Yeah, even the hash is here, and the hashed version of the password is also in there. So it's a very simple serialization, but we can take advantage of that built-in function. We don't have to write it ourselves, and we can even pass it back. So this is not how they did it. They said, well, they do say new on the string, and then we can print that out again. So we have this one, we turn it into a string, and we go back, and the result is exactly the same as before, and also the hash itself. So those are the steps we need when a user logs in. Well, rather, when a user creates an account, we get a password. We also get a username. The username and the password goes through this whole procedure. We generate a random salt. We hash it. We turn that hash struct into a string. That string and the email is saved in the database. Then, when the user tries to log in, this process runs. The username is used to extract this string, which is then passed, and then we verify those against each other. So obviously this is just a let's say demo, and we haven't hooked it up to any system yet, but we will do that in a later video. Maybe the last thing we can do is to add a new table for the user. So let's try to do that. Let's actually not do it like this. Let's go back here, and no, we need to go into projects and this one. So how was it again? I don't remember. So maybe we need to look that up. But is it just generate migration users? Okay, it's not. So let's try help. So diesel migration help. Okay, so we can say diesel migration generate users. So now we have a new migration set up that we need to fill out. And let's not do that. Let's have a look at this one. So we do want to create a table. It's going to be users. It will have an ID. It will have a, let's say an email. We'll just only have emails. We won't have usernames. And then there will be a password. And that's it. Now we also need a down version, and that's just gonna drop table users, and it doesn't need a semicolon for some reason. Right. So now what? Now we need to run it. So let's say diesel migration run. And can we try to redo it as a check? That worked. So now we should have a schema in here for users. We can go back into models, and we need to basically redo this stuff. So users, and up here we can also say users. And this one will be a user. It will have an ID. It will have an email, which is a string, and a password. But remember, this is really a serialized version of the Argan2 password hash struct, which contains information about the algorithm salt and hash. So we need this one. What's the table? It's users. And we need a new user. New user doesn't have an ID, only has an email and a password. We could also add is active here, and even is admin and things like that, but we won't do that. Maybe we'll practice our migration skills later and modify this table by adding new columns. So now we have this available. Let's actually do something like this populate DB script that adds maybe a couple of test users. So we'll say add test users, and we do need this stuff. Here we can change this to users, and we need to get a connection, and we need to create a couple of things. So let new user be a new user. And the email can be test. It's just a string. And what is the password? So maybe now is a good time to actually take this test password script and turn it into a proper utility here. So let's make a submodule called password, and let us add it in here. And that will have a function that is called hash password. And it will take a password and produce a string. And we do that by using the Argan2 package as before. We generate a random salt, we hash it, and we turn it to string in the end. So there is an error here that we probably should handle somehow. I am not sure how why would it fail? But But let's actually handle it. So this stuff needs to be a result type. And what is the error type here? No information available, because we need to actually include some stuff. Okay, still, because the parsing is broken. Let's see here. So result password hash. That does not help me, so I guess we just do result string. That did not work. Because it's returning a specific. So maybe here what we'll do is we'll map the error and we'll map it to a string. And we'll do this. And now the error is also a string. So we can get rid of this. We can get rid of the verifier because, well, that will be used in a bit. So now we can hash a password. It may fail for whatever reason, but there is. So now we should have a function that's verify password, which does the second part. So we'll need like an incoming password. We'll need, let's say, incoming password, and we'll need a password. And it should return a Boolean, I should say. And that also has to be a result. So this thing we can say, let's map the error. And we verify the password. And if that is okay, then so the result is okay if the parsing, if the verification succeeded, if the parsing succeeded. I think also verification can fail. No, it's just, that's what we saw. The verification returns okay if the password is correct, and otherwise it... so maybe... no, that you cannot do that. So we need to do this. Let's double check it just to make sure. So cargo run this one. Yeah, so the first one is okay and then nothing, and the second one is okay and password. So if it is okay, it means the password is correct. So there we go. Let's format it, and now we have those helper functions. Now we can go into the test user thing, and let's use that. Not the verify, sorry, the hash password thing. So here I think we're just gonna say it's we hash that password, and we also should unwrap it, and that's a new user. So then we need to remember how we actually add it. So the result is the users, and we so we can make it so that we can run it multiple times and it doesn't add duplicate users. So let's do the same thing I did over here. We filter on the email being equal to the new user email, and we can just take the first, and that is allowed to not be there, and if it is there, we don't do anything actually. If it's not there, we inserted the new user, and there we go. I don't want to print anything. So let's make a function called insert once, and it will take the user and the connection, and it will basically well, it doesn't have to be generic. Insert once, and a new user is a user, and there's a connection. Well, it has to be no, but we can just take ownership. It's fine. So the new user, and we need a connection, and then it just has to run this code that we have up here. So it was able to copy paste that. So now we can say insert once this new user. These usings we don't need. And then we can make a couple of users. This one will be test3, test2, and test1. And maybe these will have a new password. These will have password 2. They can each have different passwords. Right, so let's try to run that. Gotta run bin, and it's add test users. Add test users. Compiling. Right, so it ran, and then let's make also a script that lists the available users. So list users, and it can be kind of like a copy paste of this. Here we have users. We establish connection to the users. We get 100, and we need the user type. So here are the users, displaying users, and let's say for user in result we're gonna print some stuff. Print the email, and we're gonna print the password to verify. Oh, that's fine. To verify that it's stored correctly. So let's try that. List users. So here we have 3 users, test1, test2, test3. And we have some stuff. The first things are the same, of course, but then you see here's the salt and here's the hash, and those are different. And if we run this again, we should still only have 3 users, which we indeed do. And we can add users many times as we like. And still there should only be 3. All right. So I think that's gonna do it for this video. So I will see you in the next one, where we try to look at the token creation. So until then, bye bye.